Last year, when we came out here, we started to talk about something that is now a common conversation in the industry. We introduced this concept of SDVN, Software Defined Video Network. And at that point last year, we knew it was going to be a bit of an educational effort, in the sense that we were introducing a few new concepts or new technologies into the industry. First, moving from a SDI to a 10 gig Ethernet infrastructure. Second is to look at how you leverage that to improve your workflows, increase or give your facility the ability to grow and scale and be format agnostic. So we basically put this out there, and the sort of response was, wow, what is this and how do we use it? Well, since then, in the last year, we've basically delivered this. This is a real and delivered technology. And one of the things that we're starting to see now is that the conversation is starting to pick up. Yesterday, there was a great session about IP in the facility, and a lot of vendors were on that topic of how I migrate from SDI to IP. And the conversation now was how to do things, how you would try it. We've actually gone out and delivered this, and when we show you some of the numbers, it's quite impressive. So SDVN is real and it's delivered. So first and foremost, 10 plus. That's the number of EXE, which is our large size packet router, whether it's the 1152 10 gig ports or the 2304 10 gig ports switching fabric that we've shipped and delivered to customers today. And probably about 9 of them are on air as we speak. 200 plus. Some of our smaller switching fabrics to date that are in use in facilities. All right, these are 16 port, 32 port, 64 port, 10 gig packet switches. Over 500 plus IPGs, media gateways, that transition point from SDI to 10 gig. 600 plus. Well, that's the number of Magnum installs we've got to date that allows our customers to migrate from this transition from this SDI to 10 gig world. Right? One of it is the underlying infrastructure. The other part of it, of a software-defined video network, is the controller. And in this case, it's Magnum. Leveraging our existing Magnum installs to be able to now introduce 10 gig into the facility seamlessly without changing anything from the operations point. In terms of the headlines, we've seen a number of big facilities out there. Right? These are just a sampling of some of the headlines that are out there. More recent one is probably Game Creek. So when we really look at it, we have large broadcasters, large mobile trucks, large head ends, multi-channel playout facilities globally using this technology. It's not a myth, it's actual technology in deployment, in use. So we hear that it's coming, no, it's here, it's now. And that's an important thing, is that from our perspective, we've been in the front of that, and we want to continue to have that leadership in that space. So with that number of installs, with that deployment that we have, we are still taking that leadership in the transition as we migrate from SDI to IP. And this year, we're highlighting all the tools and sets that we have added to that infrastructure to continue to show that leadership. And that's all based on real-life installs, working with our end customers, and determining what they need as they migrate, understanding the challenges that they're going to encounter, and migrating to this new world. So in this case, this was something that we showed last year, and it still rings true. We've added a couple more IPG media gateways, and I'll cover a few of those. The packet switches, we're introducing our EXE28, which is our smaller form factor of our large packet switch. And again, some of the pooled resources that we've introduced also. But for the most part, it's Magnum, all right? It's our software controller. This is our SDVN orchestration and control, and this is where the real magic happens. And this is probably the most important part of the facility. It's the ability to bring all those different components together, tie them together using software, and Magnum's the way to do that. So this year, we're going to be highlighting some of the features that we're going to allow our customers to migrate. So in terms of an interface, it's a very user-friendly interface. All right? It's a web design or web interface that allows them to interact or design their own dashboards of how they want to interact with the system. These are different types of applications that are available to them that they just simply click on and drill down. Some of the tools. So as we start getting into this world of IP, questions about how do I track signals through? How do I find out where there's a problem? How do I do this? How do I? So these are this is the kind of tool set that's being presented. On the far left, I'll drill down into that, is the actual connection diagram of what's going on in the system. On the middle, you got information about the connection status to the different devices, whether we can talk to the edge devices. You find on the very right side, the control, so I can actually do my routing from this perspective. Okay. This is in fact the system that we're running on the booth. This is about a 600 source by 800 destination SDI, 3 gig SDI. It's core, but running all over 10 gig Ethernet. Okay. And we've kind of designed this to really replicate what a traditional facility would look like. You have a core, and you have little islands in which I need to connect into that core. And what we're showing here now is going to have the ability to now track signals through here, find out where they're going, how to troubleshoot that. Information about logging, what's happening in the system, who's doing the switching, who's doing the routing, where are they routing it to, all right? Keeping it all within that familiar space that they have in the facilities today. The biggest challenge one of the biggest things we're trying to address here is we don't want to change how the operators use the system. Whether it's going over an SDI or 10 gig, how you interface in the system won't change. We have to keep that simplicity that we've come to love in a facility, source, destination, take. In this case, we're also now interfacing to the multi-viewers. So instead of going to separate tools, you can go through Magnum to set up the multi-viewers, connect into any one of the multi-viewers, and go ahead and design that layout, all right? Giving them the tools right from a single control interface. The ability to design the layouts, put them back in the switch fabric, deliver it anywhere within the facility. And again, it revolves by maintaining that source destination philosophy. So using their existing control panels, hardware-based control panels, using a web interface like View Web, or a customizable user interface like View that we've introduced a few years ago, the interfaces don't change. How they interact with the system doesn't change. But we've created the tools to allow the engineering team to quickly develop or add new items to the system, set up the services that they need, and deploy them faster than ever before. In terms of the core, the big new product that we have there is going to be the VSR28. That's our smaller fabric. This is actually what's been deployed in the Game Creek Encore truck, is that smaller 1152 10 gig packet switch. So it's got 23 terabits of switching capacity and a 20 RDU. So in that case, I can switch 3,900 uncompressed 3 gig signals across that switching fabric. Some of the smaller ones, the 16, the 32, and the 64 ports are also available. So again, as we have these can be act as access points into the system. So I can have aggregation points, or I can have this as my smaller core. Gateways, okay? We need to have that transition. How do we enter into this world of 10 gig? You need gateway cards, okay? In this case, it depends on, we need to look at ways not only to get video, but audio, data, anything into this IP world. So this year, we're introducing the 570 IPG, which is really ideal for high density video signals coming in. In this case, it's a configurable module in which you've got 18 IO that can be 9 in, 9 out, leveraging the bidirectional nature of 10 gig. You've got a primary and backup path on this card. So in terms of the 10 gig interfacing into your packet core, you've got a primary and redundant path. You've got other elements on here, for example, low latency. The ability to take a video, encapsulate it, feed it into your packet core in lines, okay? Not in frames, but in lines. So in terms of being able to make that encapsulation as fast as possible. In terms of density, you're looking at 128 encapsulations in a 3RU. Again, you know, that's the highest thing you'll find in the industry. You've got in-frame buffering as well as AVM or audio video monitoring lights or TSM monitoring. So as signals come in, you can do some monitoring on the video signals as well as the outbound transport streams. The other part is that the IPG is a platform that supports these protocols that are out there in terms of how I move packets through. First and foremost, we got the SMPTE 2022-6, which is the high bit or the standard of transporting video over high bit rates. So ideal for transporting video between point A and point B, where I take the entire video payload, what's in SDI, into 10 gig and move it across. The second is the Sony NMI, or Network Media Interface, and that's where we've done a collaboration with Sony, and I'll cover that in a little bit, where what we do is in this case, we separate the video, the audio, and the data in that payload and move them as a transport stream throughout the facility, which is ideal for when we're moving into 10 gig for those live production, where I need to have the separation of video and audio and data. We're also supporting Aspen, and Aspen is a format that we're introducing as well to the market space, which actually takes the NMI to another step, where I actually route or switch video, audio, and data as separate transport streams altogether. And they're treated as individual streams that go through the fabric. Okay, and again, allowing us to really be active in that live production environment where we need that separation of traffic, or separation of data. So other gateways is our media gateways. This is our 7890 MG. Again, versatile because you've got SFP technology here. So in this case, we're not fixed to particular formats. Whatever we need at that remote location, we plug in the SFP. It takes that video, encapsulated over 10 gig, and brings it back into the core facility. You've also got a complement of SFPs that are 3 gig HDSDI. You can do AES, you can do MADI, you can do even trunked traffic with J2K encoded streams into this platform and bring it out. As well, you've got the ability to bring in control traffic over that same link. Okay, so this is ideal for those remote locations where they want to bring in signals from various venues, but they want that flexibility to bring in different types of signals. This all comes in a modular form, which fits into our modular frame. Again, same idea, where you've got a number of ports and 2 10 gig trunk ports that connect into your transport WAN. Another card that we're introducing is a high density J2K encoder decoder. All right. So what we're starting to see in the industry is a movement to JPEG 2000 to do contribution encoding, moving data from a remote site without affecting the quality of the image. So using the wavelength technology, like JPEG 2000, you can move video signals, more video signals over that 10 gig link. So in this case, this modular card will allow us to take 6 3 gig HD SDI, encode them as J2K, feed them into that 10 gig pipe, and then bring that into the core. The other part of it is it's also can be a simple encapsulator. So this is a nice versatile card where I can put that in there, license the application that we need. You can do audio, you can do MADI. Again, it's a sort of for that medium density type of gateway. In terms of leveraging our existing EQX installs, those traditional SDI core routers in the facilities that have been there since 2007, we've got a module that fits into those existing chassis. In this case, you've got an IP card, or this card fits in, takes in your baseband 3 gig HD SDI, feeds it into your crosspoint, allows you to switch it as traditional SDI in an EQX. The other element is we take that video and we encapsulate it as 10 gig, and then we feed it into our 10 gig core. So this is another way to leverage existing hardware to make that transition from SDI to 10 gig without losing the already heavily invested into the core router like an EQX. So in that case, that picture now changes from not just a 10 gig in the middle, but a bridge. So at the top we have the EQX, videos come in, we feed it into that EQX as the input card, they get encapsulated on that input card, you're now into the 10 gig packet world, and you can switch that uncompressed video over 10 gig into that packet switch. So this is one of those ways of migrating to the 10 gig world that we give to our customers. So in this case, as an example, I can take 576 video signals into our existing EQX28. They get all encapsulated, and now those signals become available into the packet world to be distributed anywhere in the facility. I can also take video signals off of that 10 gig core, feed them into the core router, and then make them available in my traditional SDI. So you have that little bridge between SDI and 10 gig. In terms of other new technology, the MVIP or IP-based multiviewer. In this case, in a 2RU, we're offering the ability to do 64 MPEG-2 H.264 monitoring, or 32 HD MPEG-2, or 16 H.264. As well, demonstrating HEVC monitoring as well. So as we're starting to move into the different codecs for distribution, as well as OTT, devices like this become very important. This year, we're also introducing a multi-layer Ethernet switch, layer 2, layer 3 switching fabric based on the development that we've done on our IPX or big packet core. And what we're starting to see here is as we move to the 10 gig world, another element here is the ability to have that control traffic go over an intelligent packet switch. And this is one of those that we're introducing here, which allows us to put our control network, Magnum, our NMS, or Vistlink, our SNMP network management system, onto a system or a Ethernet multi-layer packet switch here. One of the elements that we've built in here is that we can monitor what's going on into that switch. We know what's happening, we see what's going through that. So we've created additional tool sets and usability that isn't found in a traditional packet switch. Ultra HD will also be a big topic, really, because it's one of those technologies that's really pushing the IP agenda. It's one of the reasons why the IP agenda is out there. We're going to start seeing a lot of 4K over IP, whether it's coming from the camera manufacturers, IP production switchers for 4K or 8K. We're going to go into the IP core. So in this case, you can connect those different elements into that. And we're going to be demonstrating a world where we've got the packet core in the middle, and we're moving 4K signals across that. And in this case, we're using J2K. Another part of the tool set that's out there is, how do I, again, trying to find ways to help our customers troubleshoot that new world out there. So leveraging Vistlink, we get the ability to now really dig into that IP packet core, find out what's going on, what the bandwidth numbers are, where are the failed links, where the video, what path they're taking across that fabric. So again, these become very powerful tools that our customers are looking for to be able to troubleshoot as they would in the SDI world. Now they can do it in the 10 gig world. So again, we create different elements here, the ability to watch your bandwidth coming in, alarm when you have issues, be able to route or find the actual path that your video signal is taking across that. So again, showing the experience we've had with our installations of the things our customers really want to be able to do with this system. Not just to move the video, but to know where it's going, when it's going, how it's going. So the next step is, once we've got it in the facility and we've seen it, what else can we do? What's the next step for this technology? It really becomes this, right? And this is really where terms like virtualization, the IP-based virtual facilities start to come into play here. Leveraging a 10 gig core at the middle of the broadcast facility, tying in remote venues, whether it's a stadium, a remote studio, or even a mobile production, using that 10 gig allows us to really change how we work in this environment. So things like at-home production, where instead of having a crew sitting at the remote site doing the production, I just bring the camera feeds back into my production studios at my central location, do the entire production at that point, saving cost of that lowering the cost of that remote production. Another way to look at it is, let's say we're doing a big event. We do have a mobile environment or a mobile truck at that big sporting event, realizing that we need another replay system, we need another dream catcher. Leveraging 10 gig to grab out of a shared pool that sits in that broadcast facility, send the signals out to the core, grab the video, do the replay, and bring the output back into my production environment. So giving our customers that dynamic, that agility to grab resources when they need it, that's either physically in the vehicle or across a 10 gig connection. And then we get into the entire visualization or virtualization of playout, transcoding, and everything else. And it all gets tied in using SDVN and Magnum. In terms of Sony, one of the things that we're being demonstrated in both our both booths, it will be the interoperability of the technology. So we announced a collaboration in IBC at September last year. Here we're showing the ability to move content or signals from Sony devices through our switching fabrics into the multiviewers. So showing that collaboration in a real manner, which allows our customers to really get the best of breed solution from a production environment all the way through a playout. So in this case, this is what you'll see. So you've got video signals coming in from the Sony devices on the far left, going through that packet core and switching into all our different devices that we have there. So showing that seamless interoperability of the technology. So what else is new? Well, everything's still IP. So we got Evertz Live, which is our integrated playout. In this case, it's a dual channel device. One of the big things is it's actually going to be, we'll be demonstrating 4K playout with this. So 4K graphics with transitions and such. So now really leveraging our playout for the 4K channels that are coming up. The other element of this box is the fact that it actually has IP interfaces. So now instead of just taking traditional SDI in, we can actually take IP over, or transport streams over IP, feed those signals in, do the branding, do the transitions, the master control and such, and then put them back out as IP. So never going into the SDI world again. The other element is 10 gig interfacing. So taking uncompressed video over 10 gig Ethernet, connecting to that 10 gig packet core, taking that video in, doing those same functionality, and putting them back out as 10 gig. Virtual playout. So the technology that we developed for that 2RU device, we're now leveraging into our virtual machines. So in this case, what happens now is we take that functionality that we have in that physical hardware, just run it as software, and now install them into off-the-shelf server processors that are out there in the data centers. So what this allows our customers to do is launch channels faster at a lower cost. And in terms of disaster recovery, short-term channels and such. So that's really the next step, is to be able to not have to invest in a full hardware infrastructure, but the ability to say, you know what, I need to launch a channel in a very short time frame. Let's do it virtually. Just lease some services in a data center, run the channel from there. LiveX leverages our mediator platform to now derive nonlinear assets faster than real time. So as VOD assets or video on demand assets become available, we bring them into the system, we derive that, allow our customers to add graphics and lower thirds and other dynamic information into that VOD asset. At the same time, derive all the OTT profiles that they would need to deliver it out to their streaming customers as well, faster than real time. So in the case of a 1-hour program, we're able to derive that program in 10 minutes. So that the cost of delivering that is lower, and we can do it faster. Mediator will show some advanced analytics, resource allocation. Again, taking some of those philosophies that we're starting to see in SDVN, the ability to grab resources when we need it. We're showing that here with Mediator. In terms of sort of Dreamcatcher, one of the things is that we've been the replay choice for the 2 major leagues here. We did a press release just a couple days ago about Major League Baseball. The NBA Replay Center has been developed around Dreamcatcher as well. So those are kind of the 2 big real installs that we have of Dreamcatcher. The other thing is, we're going to be introducing a 3 channels of Ultra HD and a 3RU, so multi-camera replay for Ultra HD. Other parts that we're going to be introducing is new advanced editing tools. So the ability to edit, cut clips, do different transitions from a Dreamcatcher station faster than before. Leveraging those same suites of tool sets, we now stream them to the web. So in this case, we can take this information using our OTT encoding engines, feed them out. So in this case, an operator could look on their tablet, control the different camera angles, pull up the different playlists, run them from a web interface. This is a Adobe Premiere plugin. So again, you can edit it, take the Dreamcatcher material, feed it into an Adobe Premiere, and do the physical or do the editing there as a plugin. And lastly, the ability to do some censorship. So now doing live censorship for live programming. So appealing to the international market where we have some criteria that has to be met in terms of programming, the ability to do that in a live event. So leveraging Dreamcatcher in that space now as well. In terms of infrastructure, again, it's still an SDI world out there. We understand that, we know that's still out there. So we still have to continue to develop new technology for it with the mindset that we are making that transition to IP. So first and foremost, we've introduced a EQX10, so a smaller form factor of our very popular core router. In this case, it's a 180 by 180 3 gig HDSDI router. But again, we can input those, or we can add those input cards that we talked about earlier, those gateway cards, to allow our customers to migrate at a lower cost to the 10 gig world. Introducing this year our new RF router, which is a 128 by 128 and a 14RU. Allows you to scale up to 1024 by 1024. It leverages our very popular XRF 6RU platform. So we have a very high spec platform here. And again, it's really appealing to a lot of facilities that have a lot of needs for a large size RF router. The 7881 IRD, again, something that allows our customers to make that migration into the IP space. So signals come in over RF or ASI, and we can output them as uncompressed SDI or IP streams going into the facility. Thank you very much.